This section of Introduction to Wolfram Notebooks is about notebook features for entering programs and for making programs more readable. As a simple example, here is a short program based on the manipulate function, and as this program is being entered, mismatched brackets and incomplete command names and anything else that is even temporarily a syntax error is shown in a different color. This particular program gives a slider for adjusting a parameter in an image processing operation. A good way to check that a program like this has been entered correctly is to look for anything that is displayed in a color other than black. Any name that doesn't have a definition is shown in a different color. So for example, if the name of a command is spelled incorrectly, like the name in this example, that name will be shown in a different color. Color is also used to show syntax errors. For example, the unmatched brackets in this input are shown in a different color. You can use notebook options to make the different colors easier to see. For example, here is that notebook with option settings to show local variables like the variable r in the manipulate function in bright green, undefined names like the incomplete name shown here in large underlined magenta characters, and syntax errors like unmatched brackets in red. There are several tools specifically to help with getting all of the brackets and braces and other delimiters to match up. For example, when a closing delimiter such as a closing bracket is entered, the opening delimiter flashes briefly to indicate the matching. So in this input, as soon as the closing bracket is entered, the opening bracket flashes briefly and the color changes to black. Here is that same input with the colors set back to their defaults, which again shows the opening delimiters flashing briefly as soon as the closing delimiters are entered. Another way to find matching brackets is to click anywhere between matching brackets, which causes the nearest and closing brackets to be highlighted. A similar feature is the check balance item under the Edit menu. Positioning the cursor anywhere between matching delimiters and choosing check balance, or the keyboard shortcut, has the effect of selecting everything between and including the matching delimiters. Choosing check balance again expands the selection out to the next nearest and closing delimiters. Another related feature is repeated clicking, which can be used to select sub-expressions. For example, double-clicking the edge detect command selects the command name, and clicking 3 times selects the command as well as the arguments and the enclosing square brackets. In this example, clicking 4 times selects the arguments of the manipulate command, and clicking 5 or more times selects the entire input. These features for finding sub-expressions and matching brackets are especially useful for commands that are many lines long, where it can be difficult to locate the beginning and the end of a command. There are also several ways of using formatting to help with getting the syntax right and to improve the readability of programs. A traditional method that has been used since the early days of computer programming is indentation. For example, that program could be formatted like this, which puts matching delimiters at similar levels of indentation. Another formatting tool is conventional mathematical notation, which can be useful in programs that include any sort of mathematics. For example, here is an input to the erosion function where the second argument is a matrix, but rather than showing the matrix in a linear form with nested curly braces as in this input, that matrix can be shown in traditional mathematical notation by selecting the cell and choosing traditional form from the Convert to submenu under the Cell menu, which makes that part of the input more recognizable as a matrix. Here is another example, this time involving a program from signal processing. A key detail of this program is this bit of mathematics, which is entered here in linear programming notation, but which can be made more recognizable by formatting that formula as a fraction using either standard form or traditional form from the Convert to menu. One other formatting tool that can be useful in larger programs, especially programs much larger than this one, is to iconize parts of the program. For example, that mathematical formula can be replaced by what is basically a labeled button by using the iconize function. The iconized form can be copied and pasted like any other expression, and in a program it behaves just like the original expression. You can also iconize selections in a program. For example, in this program you can triple-click the name of the plotting function to select the part of this program that generates the plot, and then choose Iconize Selection under the Edit menu to replace that selection with an icon. There is also a keyboard shortcut for iconizing a selection, and on many platforms there is a context menu for selections that can be opened typically by Alt-clicking or Control-clicking on a selection. For example, after selecting part of the program, this shows that context menu for the selection, which includes Iconize as one of the items in the menu. In a program with expressions that have already been iconized, there are several ways to see the original expressions, one of which is to click the button with the plus sign in the iconized form and choose Uniconize. As already noted, iconized forms like this are especially useful for larger programs where the iconized forms provide a nice way to manage long blocks of code as small labeled pieces. There are many other features to help with programming that go beyond the features that were covered in this section. Often just clicking a button that pops up is a good way to find useful features. For example, the error message from this input gives a button that you can click to open a stack trace to see where the message came from, which can be useful for debugging. Also, the focus in this section is on Wolfram Notebooks, but there are many programming tools that are part of the underlying computation engine. For example, the echo function in this input shows an easy way to monitor the progress of a calculation. That's the end of the examples for this section. For the features that were covered in this section, you can find more information in the Wolfram documentation, and in particular, you can find more information about syntax coloring, bracket matching, and related topics in this tutorial on using the input assistant.